Hello everybody and welcome back to the channel. This is Michael, KE4EST. And today on the workbench here I have acquired a Superior Instruments Company, or SICO, Model 76 CR bridge and signal tracer, or that's capacitance, resistance, bridge, and signal tracer. I got this at a Hamfest I went to recently. Yeah, I had it sitting there and I was looking at it and don't know if it works or not, but the cord on it's good, but so I don't know. But anyway, we're gonna find out anyway. But first, of course, we're gonna open this thing up and check it out and look at it and see what needs to be replaced. Probably some electrolytics in here. Alright, let's start by looking at it here before we take it apart. So what this is, what they used back then is this is a capacitance and resistance bridge. So if you had an unknown capacitance or a resistor, if you had a capacitor or resistor, you didn't know what it was, you could put it across here, put it in the bridge mode, and of course that'd be turned on. You could look at this magic eye. This one was magic eye tubes you could look at. You're looking at, the eye opens and closes. You're looking for the most opening part of it. So you hook your capacitor up to it, and you could run it across here. And when that eye opens, if you remember my earlier video, I did a SICO model C20, I believe it was, that I restored it. Same thing like that. You put it on there, adjust it until it get it where it just right there's where it's mostly open, and you read over here and see what the capacitance is. Or if you're checking the capacitor resistor to see if it's still within tolerance or what it's supposed to be, put it on here, check it. This one also I see has a leakage. So you would press this down, it's spring loaded, and hold it and look. You wouldn't even use the eye for that, you use this leakage indicator here. And if this comes on, then the capacitor's got internal leakage, not physically leaking out goo or anything, but the leakage inside of it's like it's starting to turn into a resistor. So you would hold that down and see, and if it don't open, then it's fine. I don't know. I've got to look at the schematic and stuff on this, but I don't see no way to change the voltage, or so how they're doing it, I'm not real sure. It's probably, throwing a voltage across it and checking, like some of the other ones do, but it's got a power factor over here where I can check the power factor of the resistor, or the power factor of the capacitor, but there's no way to set the voltage, so I don't know what voltage they're using or whatever, but it's obviously a fixed voltage. So that usually, though, sometimes though the lower voltage can give you a relative indication. It may not be perfect. You wouldn't want to use this for trying to reform a capacitor or anything like that, but you can hold it down for a few seconds, and if that lights up, then better replace that capacitor. And then it's also got a signal tracer mode. It doesn't appear to be, it'll open it up here in just a minute, but have any, there's no, I looked around, I don't see any speaker on this thing. So you got your signal tracer input here, and then you would, hook your probe up here. You could search around in the circuit, listening, for any noise, or trace the signal. So you got a receiver or something, or you got an amplifier. Set your signal generator to feed a signal into it, and you could go from stage to stage and amplifier, and boop, boop, boop. There's the signal all the way through, and then over here it's not there. I'm not getting it. But it shows here hooking headphones into it, which I'm guessing is probably like a 2,000 ohm impedance headphones from back in the time period. There's no speaker on this thing. I can see holes for a speaker. And there's no... only thing we got back here is one of these jacks, and that's probably for a take your VTVM. Yep, see it plugs right in there. It grabs it, and you can read a DC voltage. As you're hunting the signal, so you can watch the needle move. If you don't want to use the headphones, and this here probably opens and closes as it finds a signal. You know. So we'll see. I'll go through the schematic. And also I noticed here too, I've never seen one like this personally. But this has got TV antenna in feet. So, and it's got 72 ohm coax, or like 75 ohms, close enough, we use today, and 300 ohm ribbon cable. So you can go through and find, see if there's a break in your coax. It's got the feet marked off here. So that's interesting. But anyway, I see a little bit of glue on the side of the knob here, and this thing keeps, if you can hear that, but it keeps, maybe you can hear that. I don't want to do that too much. It's scratching the numbers here. These are raised. So that's got to be fixed. But anyway, so that's it. I mean, you've seen the back of it. It's got a plug. It's kind of flopping around there. I've took the screws out of it already. And like I said, this would be for, pretty sure that's hooked up a VTVM. So there it is. So I've already took the screws. I had two screws in the back here, two little tiny screws. And then on the sides here, you can see there was one up here and one down here, and then the same thing on the other side over here. So there's 1, 2, 3, 4, and then 2 in the back. So here we go. Okay, that come open pretty good. Let's see the vacuum tube. Okay. Well, so let's leave that attached, but move it out of the way for now. Let's see, where do we start with this thing? Well, look at this. Start with this. I don't know. Not much like that being wadded up in there like that, but that's the way it was. There's no strain relief or anything here. You can see it's just going off over here to the power switch. So that's interesting. Let's see, make sure I ain't gonna hurt anything or setting it down like that. Might as well start here. Move the camera just a little bit. Okay, so here is, yeah, there's your power transformer. Comes in here, this power transformer. What tube is this? 1626. Okay. I'm trying to trace the leads here real quick. Yeah, okay. So using this for the rectifier tube. Okay, and then, alright. Got a capacitor can over here. The rectifier tube's back over here. Then we got a oh, that's a 0.1. Okay, so this is definitely our filter can here. Okay, oh, I see all kinds of interesting stuff with this thing. Alright, so that's probably a 12C8. Says VT-153, so that would be an Army, or maybe I should say military numbering system there. Sure does look like a 12C8 to me. 1626 tube here. Okay. some kind of rectifier tube, I guess. Not real familiar with that one. And this is obviously Magic Eye tube. It's probably 1620. Yep, 1629 Sylvania. It's also got a number on it. It says BT-138. I'm trying to look and see if this tube here, I might be making me sick flipping this thing all around. I'm trying to see if this had any other marking on it, but nope. I'll have to see. Hang on just a second, I'll look that up. Alright, went to our friend Google, and yes, this is a 12C8. A lot of them use it. Heath Kit signal tracers use these. This right here is not a plate cap. This is a grid cap. This is, you can see too, I mean, it's coming right in off of the input of the signal tracer. For your probe would go in through a capacitor right into there. Okay, and this should be going off to ground. Yeah, so that's going to ground there. So this here is your signal path coming in here. Okay, and this is a 1 meg resistor, so there's 1 meg input impedance there. So, okay, we've seen that. Now let's look. Big wad of wire out of the way here. This is a big old fat capacitor. That'll get replaced. Let's see, of course I replace all these waxies. I can see we got a mix here. Do we have a mix? No. Yeah, we do. Let's see. This here. Let me see here. That's a roundy. That's a wire wound. We'll have to check that out. That's a roundy. That's a roundy. That one up top I was showing you is a roundy. It's a little quarter watt. This one up here I was talking about is quarter watt. It's definitely a roundy. I see roundies all in this thing. So, you know what? With the roundies, depends on how this thing's been stored over the years. Sometimes they can be fine. You can check 2 or 3 or 4 of them. They're all pretty much in tolerance. The rest of them probably are. So you're probably kind of safe to go ahead and just leave them in there. Something like this being it's got a bridge circuit, signal tracer. You know, it's gonna mess with readings and all that stuff. So that definitely have to be changed out. So all these roundies will have to go. These waxies are way past their time. They have to go. This resistor here, 200M. That's probably 200K, because here we got a 2.2K, or yeah, 2.2K right here, and 200M. This will be part of your bridge circuit. Yeah, this come down here. That'll be part of your bridge circuit. Back in the day, they put an M, meaning 1,000. So 200,000. We'll test that. That's probably, let's see. Let's check that. If I can, I don't know if that's going to be in the shot or not. Let's check that. That's probably a 200K. Well, you see what I see? That's showing 273K. So it's definitely 200K. Or supposed to be. And we're showing 273. That's way out of tolerance there. So that'll have to go. Well, yeah, it's definitely going to have to go. Look at this. Let me see if you can see this here. Let me move the camera and zoom in. You look right here. That's cracked and split open. And let's see, it's going to be sitting like this. Yep, see this? There's actually, something to get back over here where you can see it. Get this thing zoomed in. It's cracked here, and there's actually something leaked out here on that. So that's interesting. So, yep, that's got to go. And then what I was saying earlier, right here, this looks really interesting. Is that a bodge? Is that a... That just looks like... I mean, see, this resistor is completely different than anything. Look at that. It was tack sorted, but look at that. That's come loose. That's definitely been added. So that's interesting. Never know what you'll find in these things. And this can, look at this can here. Here's the, let me get you on the, well, let's see, what's the best. Get you, we can see the bottom of this can here. Got one wire hooked up, which goes here, goes around. Yeah, so that's your filter. Of course, these two tabs aren't hooked up. Yeah, those two tabs aren't hooked up, and they don't have any solder residue or anything where they've been hooked up at all. And yeah, you can't really see this on camera. I'm trying to squeeze it down in there and look, because it's back in here. Yeah, this can's got definitely three capacitors in it. One 10 microfarad and two 20 microfarads. A 10 microfarad for 50 volt, and two 20 microfarads at 25 volt. But it's never been used even originally. So that's interesting. I guess, you know, sometimes that's what they have. You know, they're like, why did they waste all that or whatever? They had ordered 100,000 of these things to put these things together, or if it's, you know, I don't know if this one was sold as a kit or not. You know, if they ship it out in their kits, or if they ship it out at the factory. When they make them at the factory, they'll have, from something else that they made, they had a bunch of these left over, and we got to use them up. You know, the bean counters are like, well, we got all these, let's find somewhere to do with these things. And they're like, well, we got to put them somewhere. You know, we're planning on making a production run of 50,000 of these units. We got 100,000 of those, so plenty enough. So stick them in this. You know, so I don't know why they go with that and waste two capacitors. So that's probably the reason. Let's see. But that's it. All these caps have to go. Most of these resistors have to go. This will go. Check the tubes out. Hopefully this 1629 is still good. And we'll get a schematic and go over it and all that good stuff. So when I get that, I'll be back with more information. Okay, so I have located the schematic, and it's got a date of 1956 down here, November the 14th, for this Model 76 for this Superior Instruments Company. And I've already started going through some things, and very interesting. It's not matching. There's several things that's not matching what's on here to what's installed. And remember that resistor that was just tacked to the back of that potentiometer that I popped off? It looked like it was a bodge or somebody added it down the road. It's not in this schematic at all. So I'll have to go over that more when I do get the restore done on it. And I'll go over some of that stuff and what I did and what was different and all that. But anyway, here's the schematic. So we got your we got the so here we got, of course, our AC line coming in, going to this transformer. We got 55 volts out here. We got a winding 117 volts. It's going in here, and this is 1626. It's a triode, looks like. Connected up as a, as you can see, this 1626 triode, just using it as a half-wave rectifier. They've tied the control grid and the plate together, and then the cathode. Another one of those, why did they do that? You know, maybe they had a bunch of these they want to get rid of. I don't know. But here's that 10 microfarad capacitor and their filtering here, and this will feed voltage off, you know, to the rest of the circuit. We got going up here to the plate of the magic eye tube. We got it coming up going to here, which would be your leakage. So it says 117 volts, so it's almost like a 1-to-1 here coming off. So it's 100 some volts rectified here, and then we got a dropping resistor. So I have to measure that and see what that puts out when we get it going. And then it feeds here, the high voltage, which will go up here to the plate of the 12C8. And you see on this, it says 12C8 on the schematic. And it's, see, feeding over to there. And then we got 55 volts here. Coming around. So using 55 volts here on the bridge, which is AC, you know, going across here, for the bridge circuit. It comes up and across. If you got this flipped in the bridge side, it will, let's see, come down across to the magic eye tube. So, and then it does work in tracer. I was wondering about that, if the magic eye tube would work, if it was just working in the bridge or it worked in the tracer too. But it does. So you have the magic eye tube if you're in tracer. You can have the headphones here, or you can have, here it says on back of instrument. This would be, you can see how this would come across here, coming off of here. You'd have a voltage right there. So I was right about that part. So I mean, it's pretty simple schematic, and I thought it might be with just a phone jack on the front, no speaker. I couldn't find, there is no speaker, there's no another stage. You know, if you look at some of these other signal tracers, like Heathkit and some of the other ones, they'll have a 12C8, and then that'll feed into something else like a 12SH7 or something like that, or SN7. This comes straight out of your signal will come in here through this blocking capacitor, and there's that, they're showing 1.2 meg here, but it actually is a 1 meg resistor. And then it's coming right into the grid here, which you can see coming off the plate, and going through a blocking capacitor right out to the headphone jack. Coming back in here, and let's see, and that goes off to the magic eye tube. This goes to the back so you can put a meter on it. Okay, I see what they're doing. I was trying to look at all this. What they're doing, if you plug in set headphones, it looks like to me that it'll go straight to the headphones. See, this will break, and that'll be it. If you don't use headphones, you can have the magic eye tube and this, you know, to hook to a VTVM, which I guess it wouldn't have to be a VTVM. And then they're feeding back here to a diode for what? So you can see. So I was looking at this. Yeah, if you plug phones in here, this will be disconnected. So you just have headphones. If you unplug the headphones, this circuit here will be tied in so that you can get. So you got a plate. You got inside this 12C8. You know, you got this, and you also got this. There's diode in there. Actually, there's two of them. You can use a diode here. There's a plate and a cathode, and there's another one, plate and a cathode. If you look up a 12C8, I don't know if they got them both tied or just using that one. Then you'll get a voltage here off of this to drive that and to drive the Magic Eye tube. And the biasing's right here's your biasing circuit. The 1K resistor lifts this tube up from ground enough to, you know, put some kind of bias on the tube here. So there's that. It even shows you down here, it didn't come with any probes, but if it's an audio probe, straight through. If you want an RF probe, there's a schematic if you want to build your own. Now they want to use the RF probe. You want to, probe RF circuit, like an IF or something like that. So, and of course here's your bridge. I'm kind of all over this thing, but I've been all over this thing mainly trying to just trace it out, and it's interesting. But when we get to that point and I show it restored, we'll go over that, and I'll show you what wouldn't, like all these 1.2, 1.2, 1.2, 1.2 megs are all 1 meg there, which is fine. Most of this is just, there's no 1.2 meg, 1 meg, it was going to be fine in the circuit. And they probably had a bunch of 1 megs, and that's what they stuck in there. But some of the other things is kind of interesting, but we'll go over that when I show you it restored. And I get that all done, I'll be back with the restored unit and we'll fire it up. Alright everybody, I thought I'd stop right here and show you what I've done so far. I have pretty much got this thing ready. You can see here, I'm just trying to hold it up here so it's going to be a little wobbly. You can see I have changed out, and this one's not been changed yet. This is just the current limit for the neon bulb. It's supposed to be 470K on Schematic. Somebody's got 2 meg in here, and it's a rounding. I'm going to change that. I think decided if I'm going to stay 2 meg, or drop it back to 470K or whatever. So I'm going to start with 2 meg. This is reading pretty close to 2 meg. So I'm going to go with that. Start with and see what I think about it and go from there. But other than that, I have changed out every part in here except for, let me get something to point with here. This capacitor is good, so I didn't change it. And this resistor here has not been changed, and this resistor here. Other than that, some of them's hard to see back in here and around. I'm trying to move it here, but every capacitor, every resistor, except for the 1, 2, 3 I showed you, or 1, 2, 3 here, and this one here will be changed. I can't see it on the camera right now, but that one there, neon bulb will be changed out. So I just want to show you what I've got there. I've done all that. Everything under here has been all changed out. Got rid of that big gigantic, well, where did it go? Everything's if you see the workbench here, you see it's a mess because I've got parts everywhere, and I went in drawers and pulled out parts, and I'm in the process of it here, but oh, there it is. There's that really big 2 microfarad capacitor that I pulled out, and it's been replaced with this 2.2 microfarad, which is close enough. I know in modern day it's easy to get 2.2. I've got it in this, and I've got some like this here, these Illinois capacitor. Like here's a 0.47. This happens to be laying here. I've got some 2.2s a little bit fatter than this and a little bigger. But trying to do the like this type thing, so I've got some of these too that are brand new, and these are really good capacitors too. So I just like these. I don't know what it is. I always like these little yellow Illinois capacitor ones. But anyway, so I've done that. Changed out most of the lead dressing. Made that look a lot better than well, it fell off. But here, this fell off of this capacitor here. It just looks like a piece of somebody stripped a wire out. You know, like a number 14 wire or something, and used that. And then there was some pieces like this, these clear plastic ones, which are fine. I've got some of these more newer, a little stiffer. This feels like a gel rubber almost, but you know, it's plastic, but it feels like I wouldn't describe it as, but it's how soft it is. But I've got some more. This here is a harder insulation. I've got some like this. It's clear, but I think that looks good. Here I've that 200k resistor. It was a 10 watt 200k resistor, and I'm telling you, trying to find one of those. I thought I had, so I went through and I said, I've got some. It was a new old stock I'd got somewhere before out of something. Nope, they weren't. So I got online, looked around. No, I'm not let's say I'm gonna paint arm and leg. So I had plenty of these. These are inside of this. Let me move the camera a little bit better here. Inside of this here are 1% tolerance, and when I measure this, it came out right at 200k. But they're 1% tolerance. They're 2 watt 1 meg resistors. So of course, and I got 5 of them paralleled up. So you put 5 in parallel, and you can do the math. But it's gonna come out 200k. So because I was like, how am I going to do this? And then I thought, well, I could parallel something, and I'm like, well, now wait a minute, 1k will be perfect, or 1 meg would be perfect. And I was digging around, and I found some 2 watts. So this essentially gives me a 10 watt 200k resistor. This is heat shrink tube, and I've got over it a couple different colors here. But there's this this is that can capacitor. Usually I snip all these off so they're, you know, out of the way or whatever, but nothing's touching anywhere near it. It's not being used at all. This is let's see, I've got this zoomed in. I don't know if you can. Right here, this here took place of that can here, that big can. So I've replaced that with that. So there you go. So it sure did clean it up and look a whole lot better. I think it's a lot better. Now, these are those pin type. They're not, you know, these here are not banana jacks. Remember them old pin type? And you know, this, get it, it's all tangled here. See, it's not even, it's a little bit bigger than, you know, a test lead, but it's not as big as it's not as big, you know, like an alligator plug like this here. It just, you know, it won't fit. So I researched this, and these, I forget what they're exactly called, and there's some place you can get these and still get the ends to make connectors up with them. So right now I've got them left in there. I may just change these out with banana. I don't know. And this down here, this RCA jack that they're using for the signal tracer lead, I think I'm just going to leave it. I was going to change that and put a BNC, but this will probably be more of a shelf queen than it will be used, but we'll see. But if I decide to start using this, or because I would like this, to have like another stage of amplification in it, and a built-in speaker for the signal tracer part, maybe an RF switch. There's some things that could be better with it. So it's, I think more like I'd rather have this as a shelf queen than actually use it. But I don't know. I've surprised myself on things before. I think, well, I'm going to fix this up and set it up for looks, and then next thing you know, it's on the workbench and it gets used a lot. So let's see. Up here, I'm trying to leave it zoomed in, but look here so I can get it. White balance is trying to act funny here. I changed out this resistor here, this capacitor coming in to the grid cap, and then on the back of the 1629 Magic Eye tube, I changed out those two resistors there. They were them little roundy things, and these are 1/4 watt roundies. This thing's full of them, as you've seen, earlier. But everything I buy, if I see, these Allen Bradley style and the good ones from a reputable place, I get 1/2 watts or higher. So I don't even know if I've got any 1/4 watts. I know they make 1/8 watts, and I know they made 1/4 watts, but I don't even think I have any. So there's that. It's pretty much ready to fire up. Now I've cleaned up the face, done all that, but now here I want to show you this here. Here's the knob that goes on the front with the pointer, which is just about, if you hold it just right, I won't be able to see it on camera, I can get it just right, and I can see the line still, but it's faded out, and it's, if you look back here, from here it's good, but up here it's just faded out or whatever. So, and I wanted to show you this. Somebody has glued this on, either glued it back on with some kind of really, what they used there. It didn't dry clear, and I don't know if you can see it on camera. We'll try, but it's warped. So even though, and this here too, I'm not sure if this was done when somebody built, I'm almost wanting to think somebody built this as a kit. And maybe all these potentiometers came, with the long shafts. Like, a lot of times you can buy a replacement potentiometer and it's got a real long shaft, sticking out on it. Put this up here. It'll have a long shaft, sticking out on it. And then you just cut it size you need. And you can see somebody's cut this one. It really should be just a little bit longer. But to get this in here, so I can, put these two set screws, tighten them up. It's almost, got to be real close, which is fine. Let's see if we can see. There's a pretty good little gap there. But with this being warped here, that's still dragging. So I think what I'm going to try to do is I'm going to put this in a vise very carefully and heat this up and see if I can bend it, because it's, I don't mean bend it back this way so it won't scrape, but so I don't know if you can see that on camera. I really don't know if you can or not, but it needs to be, you can see me flexing it here, it needs to be more that way. When that go and it goes whoop, it's like that, and it's kind of crooked. It needs to be straight, but it's crooked up like this here. So I think I'm gonna try to heat that up, with the heat gun and see if I can get it to stay that way. So that way it won't scratch. And then I've got to figure out, like I said, I can see it. If I hold it down here and look at it, you know, from my angle over here, I can see. I don't know if you can see it on camera. Yeah, it's just too hard. But you can still see a line through there. It's definitely there. But it's just gotten knocked off or something. And this is... So since it's already off, I tried to clean this up some, and I thought it was like, you know, nicotine or tar cigarette or whatever. It's real brown looking, but I've put some pretty good chemical on it, and it's still got a smoke tint to it. So maybe factory had a smoke tint to it instead of being clear. I'm gonna try that, see if I can straighten that out, and get this thing ready to fire up, and we'll see how accurate it is. All right, everybody. So, here it is. It's all finished up. Put back together. And we'll do some testing with this thing. So I showed you everything I did to the inside. I went ahead and put the case back on, put the screws back in. Got some test leads ready. Let me go ahead and take these out though, show you that I did. Like you can see right here, I did go ahead and change out the original jacks, because I thought, you know, this stuff I might set up on the shelf, but then I want to end up using it or something, and then I gotta find an adapter or something, or get something to stick something so it'll go in there. So you can see how shiny, or that definitely ain't something that's been around for 50 years or more. So here's the I put new jacks in here, so they're proper, you know, or modern day size banana jacks. And up here, I just left those holes there, but I drilled out those rivets and put in a B and C jack so that I could use it if I wanted to for a signal tracer. So let's, oh, the other thing I did too is this did straighten out here, and what I did to get the red line back on it, like I said, you could barely see it in the camera. You could see where that line was. If you look at it just like this here, you couldn't see the line. If you hold the light just right and you have the knob off and look at it, you could see the line. You could see the line, you know, and see kind of where it was at. So what I did was, well, I ain't gonna kind of show you exactly here, but I took it, and you could barely, like, say this here, you can barely see the line. Say this between my fingers here. If I tilt it just right and hold it right, I could see it. So I took some of that blue painter's tape and very carefully went down. And of course at the bottom I was showing you down here, it was still nice and bright line, and you could still, like I said, still see it good enough to very carefully put that in there. But put tape right up to the edge of the old line. And then put tape right to this other line. If you hold it back at distance, it almost looked like you just had two pieces of tape stuck together. It was so close. And then, but of course up close you could see it, there was a little bit of a gap in it. And I just took a regular Sharpie brand Sharpie, one of those, I've got some of those ones that's called industrial. It's supposed to be more permanent than the regular ones, I guess. And just run it up through there a couple times and let it dry, and just peel the tape off. So now I've got my indicator, and I took this, stuck it in the vise, and very carefully hit it with the heat gun, and boy, that stuff is really malleable. Heats up real quick and easy. If you do one of these, be very careful. You get too hot too quick, and it'll just, you'll have a mess. You'll make it worse than it was. So be very careful. I almost got this one too hot. But anyway, so let's fire this up. I think, well, let's just see. Turn on the supply over there. Let's go ahead and flip it on. You might be able to see the magic eye tube on the camera with the light I've got on it. If not, I'll move the light. You see it's warming up there. Yeah, you're seeing that. Okay. So I'll go ahead and plug in some leads here to it real quick. Just kind of go over it. So let's start off with brand new. What we set at here. Oh, that's good. We'll start with a new capacitor here. Like some of these you see me grab out and use for when I'm showing things or I'm testing or whatever. And you can see I've already found the full end on this one here because I put a dot. This is a brand new capacitor. You can see it's a 0.1 microfarad. Get the light just right there. So let me just push this back just a little bit. You can still see it. You should be able to still see it okay. I got a little more room here to work on the bench here. Let me put these leads across it. And I've got one in the common side and one in the capacitor side. And of course this is non-polarized capacitor. If it was a polarized capacitor, say it's something like this here, you want to make sure you put these in right, especially when you hit, if you want to do a leakage test, because when it throws voltage across it and you got capacitor in backwards, you could pop the capacitor. So that's in there. Oop, stay up there. Let's see, let's move the light. There we go. You can see that, yeah. You can see that. Bring it in just a little bit more. So you can see that eye open and close. And so what you would do, if you just want to check a capacitor value, is you make sure you got your range here set. And if you don't know what it is, you'd want to start at the top and work your way back. But this one here is marked. So we're going to put it. Another thing too is, like, especially when you do a leakage test, this puts about 100 volts on it for a leakage test. So keep that in mind too. You don't want some of the, back when this came out, most capacitors were at least 100 volts. There was 200s and 250s and 400s and 500s and stuff like that. So keep in mind of that if you're going to use one of these. And of course this here is insulated that I'm holding on to right here. But we got this in here. And you want to make sure it's on the bridge mode. And like this one's marked, so I'm going to put it from 0.1 to 50 microfarads. And if you see right here, reading this way, capacitance is on the inside here. Okay. And it says 0.1. And up here it shows 0.5. And then there's 0.2, 0.3, 0.4. And as you turn this, you look for the maximum opening of this eye. There. And you can see, I've got the light dimmed down a little bit here, but you can still see that. Move the camera just a hair. You can still see that's pretty close. Right on it. If you remember too, inside when I was first showing it, there was these extra resistors and capacitors tacked in. Like that big capacitor I changed out, that was that big black, oiled filled thing I took out and put in that poly cap. There was somebody had tacked a 0.1 microfarad across that wasn't in the schematic, and I pulled it out. And so, you could do that. So, if there's nothing inside of here to, like something to stick a tuning wand in and tune this thing or anything. It's built so simple. So that would be the way you tune it if you use this a lot. And I can tell this one was probably used a lot. At least it was left on a lot, because this magic eye tube would be a lot brighter than this. But if you're going to actually use this not for a hobby or something, it's going to be close enough. It's no big deal. But if you're using this on a workbench, service shop and you need something that's pretty close, pretty accurate, that's one thing you could do. If you had another one, like you could take it to your buddy or to another shop or something that's got more money than your shop does and has a fancier thing, or if you got a bunch of capacitors that's real low, tolerance on them, and you're like, well, these all should be 0.1. This one's got a 1% tolerance capacitor. Well, back then I think 5% would have been about the best you'd see. Just like now, it's hard to get a capacitor that's closer than that, but you get what I'm saying. And if this was reading, every time you put a 0.1 in, it's reading up here, the maximum spot, instead of down here. You could go in and tack a resistor across and parallel to add resistance. Maybe stick one in series to drop the resistance, or drop the resistance a little bit. You could tack a capacitor across to raise the capacitance a little bit. One in series, drop it a little bit. Maybe change, play with the bridge, put a resistor in line or something, or change out a value resistor. Things like that. So that's been what somebody had done. Of course, they did a sloppy job at it, but that may have been what they were trying to accomplish there. That's the only reason I can see that stuff, because when I got to really looking at it and replacing parts, I seen that some of those, they were like across things in the bridge circuit, or in series with things in the bridge circuit. So I was like, okay, I see what they're doing. But anyway, that one's reading pretty close. And then if you're in the 0.1 to 50 or 20 to 1,000 microfarad, you got this power factor over here. And what you want to do is tune this for the maximum opening. And the maximum opening is down as far as it'll go. And the lower the number, the better. If you're up here, this power factor ain't gonna do anything. It's not even in circuit. It only works here. And so you can bring that up, and so if you get up to around 15 or so and it was opening, it's starting to get bad, about time to it's, some people say it's past 30 on these before you throw them away, but and then kinda nowadays capacitors are relatively cheap. Some there's no relative to it. They're just cheap. So it's just better just replace them. You get up 10, 15, I'd just replace it. Not even worry about it. So that's how that works on that. And then we could check the leakage. You've got this here, the little neon bulb in there. And what you want to do is press this down and hold it for a few seconds. And it's okay if you see that flicker like you did. But if that starts flashing, or if it comes on and stays on, then it's got leakage. And you can see, this is brand new capacitor. These are them good Illinois capacitors, so there's nothing there. The only thing I tell you about this is, I don't know if I'll move the camera again, put it in shot, but there's still voltage across that. Even when you let go, there's no circuit in there to discharge that. So what you'll have to do, I've got a capacitor discharge. You want to put the because right now if I take this off, I don't want to touch that. Let's check it and see here. Yep, there was voltage across it. Now it's discharged, but you can touch it. But about 100 volts across that thing. So keep that in mind. All right, so let's check out some resistor or two here real quick. So this, try to shorten this up a little bit here. I know this video's gotten really long. Here is a 82K that I was using for something and then decided not to use it, so it's brand new. You can put lead dressing on it. 82K, so we'll go over here to resistance. And resistance on the outside, so see we're starting off here's 100 ohms, 500 ohms, 1000 ohms, all the way around 10,000 ohms, 50,000 ohms. And then make sure you take this and put it in the resistance side. Okay. And then I've got it on R times 100. Got the resistor, got it on the resistance side here. I've moved this over to here. So 82K would be about right in here where this 0.8 is. Because here's 500 ohms, 600 ohms, 700 ohms, 800 ohms, 900 ohms. So 800 ohms times 100 is 80K. So it should be a little past the 8 right there. And well, it is just a little past it. This here would be 85 right there, so I'd almost want to call that 81. Let's put this on here and see what this says. Push that. Well, 81.434, so pretty close. That's pretty close. So that's pretty good. What have I got here? Let's see what we got here. Here is a new old stock 1K Allen Bradley. Let's stick that in there and see what we got here. So 1K should be right there. And it's showing, I would say, like 910 ohms. I doubt that's that far off. Let's see. See about that. 950 ohms. So the resistance side there is, a little bit off. So you could go across the resistor in this bridge and maybe tack another resistor across it, put one in series, trying to change that value a little bit to get it more accurate so that it would read up here. So that's something you can do, when you're inside of it. And real quick, let's do one other thing. Let's put it tracer mode. And what I'm going to do, this just a quick test, is I'm going to use a oscilloscope probe in 1X. And we will see. Now watch that eye. If it comes near me, because my body's picking up the 60 cycle in the room. So that part's working there. And I'm gonna take it over here on my signal generator, set to about 1000 hertz. Well, let's see if it picks this up here. I come near it, so I had it in circuit. Wow, I'm not even touching it. I'm really close to the test lead on the signal generator. So that works pretty good, so you can see it there. And of course, taking headphones up here is going to be kind of hard to demonstrate on camera, so I won't go there, but we see it works. So, pretty good. Another thing, remember, when something like this, use it and turn it off. When you get ready to use it again, a lot of times, I'm guilty of, I have a bunch of stuff on my bench, and some stuff I've got hooked up to switches, so I can just flip a couple of switches and 4 or 5 pieces of test equipment becomes live. And then I just kill, a couple switches and kill everything, that way, if I forget to turn something off, well, you got a habit of flipping those switches, before you leave, so it's off. Except for like my, the 10 megahertz that I use, things like that, you know, references and things I leave on all the time, a lot of times, but power supplies I usually leave on. But something like this, I'm talking about solid state linear supplies, things like that. But turn it off. It's not, you know, it's going to be okay because it comes up pretty quick. You know, you get ready, you want to test something, turn it on, and it takes it about, what, 11 to 15 seconds. It's coming up here. It's ready to use. You can start using it. You're going to test a few parts. That's fine. Leave it on. You're done testing the parts you're going to test, and you still say you're going to stay and do some more work. Go ahead and flip it off when you're done. Because the longer these eye tubes are on, I mean, they'll last for a pretty good long time, but they get dimmer and dimmer and dimmer. And a lot of times what happens, you know, in the shop, these things are left on all day long. So it's ready to test, hooked up. Sometimes they're left on for days and weeks at some of these, you know, shops. And these eye tubes, you know, start getting weaker and weaker and weaker. So that's good, you know, with something like this, just flip it off when you're done using it. But other than that, there it is, the Model 76 from Superior Instruments Company, or SICO, SICO. The CR bridge and signal tracer, or capacitive and resistive bridge and signal tracer. There's the restore. I hope you've enjoyed it. I hope it's helped somebody out. If you got one you want to restore, I hope me going through this and showing you everything I did help you get yours going back. And if you've got one, and I'd love to hear it in the comments, or if you stored something like it, or if you had anything like this, let me know. If you've liked this video, hit that thumbs up. Let me know in the comments if you like my videos spread out, like part 1, 2, and 3, so you can kind of pick what you want, or if you like these long videos where I really go in detail on things. And if you've not subscribed, subscribe for more videos like this and stuff coming in the future. So until the next video, this is Michael, KE4EST 73.